Today we're going to discuss how we measure motion. Well, first let's define what motion is. What is motion? Motion is a change in position during a specific amount of time. Motion is measured relative to an observer. So whoever's watching the motion occur is going to be measuring the motion. That is known as relative motion. So relative motion is motion from the point of view of the observer. So whoever's watching the motion occur. For instance, if you were standing on a train platform and a train comes flying by with all the passengers in it, it looks like they're moving to you. But from the passenger's point of view, if I'm sitting inside the train and I look out the window, it looks like all of these train platforms and these trees and these objects are moving in the opposite direction of me because I'm sitting still. Okay? So if you want to think about it like this, relative motion could be from the point of view of the observer. One observer would be from the platform, from the train platform. The other position would be from the train, from the passenger on the train. Okay? So from the platform, the train appears to move. And from the passenger on the train, the platform appears to move. And that's what we describe as relative motion. And you'll see here we have this train. So for all the folks sitting here in the train, they're sitting still. They look out the window and they see this guy standing over here, and he appears to be moving in the opposite direction of the train. If they look out the other window and these two trains are going the same speed, they would look like there's no relative motion because they'd be sitting next to each other. You may have experienced this if you're sitting in the parking lot and you're just sitting in your car, gazing out the window, and all of a sudden you think your car's moving, but it's really just the car next to you backing out of the parking spot. So you feel like you're moving forward. You're like, whoa! So in order to describe motion or realize that motion is occurring, it's all relative to the observer. So for this guy standing here, the train is moving, okay, to the right. For all these people inside the train, this guy standing there is moving to the left. Okay? Now, how do you know you're moving? Well, you know you're moving because you understand that trees and all these things you might have sitting over here, okay? You know from life experience that trees don't get up and run around. So you know that tree's not running in the opposite direction of you. So you can reason that you are moving even though you are sitting still. Okay? So you're sitting still in the train, but the train is moving. You know that because you know that trees don't move. But if you were standing here outside next to the tree, you'd be sitting still and you would say, hey, that train's moving to the right. Now, the people sitting in this train moving to the right, looking at the people moving in this train moving to the left, these people feel like they're sitting still and that train's moving. These people in the train moving to the left feel like they're sitting still and the other train's moving. So it's all relative to the observer and where that observer is. If you have any questions about this, please come ask us as we circulate through the classroom. We'll be happy to answer any questions you have. Jot them down right now and write them down, and then that way we can go over it in class. And as you're working on the reading and the labs and the activities, you can ask us questions, okay? We'll see you soon.